This is an example like 1.6 problem 3 in the WebAssign. Here we're given a graph for f of x and a graph for g of x, and we want to evaluate some limits here. So here we've got the limit of f of x plus 2g of x. So by the limit laws here, that's equal to the limit of f of x plus the limit of 2 times g of x. And then also by, and these are both as x approaches 3. And then also by the limit laws, this 2 will come out in front. So this is equal then to the limit of f of x as x approaches 3 plus 2 times the limit of g of x as x approaches 3. So as x gets close to 3, we want to see what does f of x get close to. So 1, 2, 3. So here's 3. So as x gets close to 3 from either direction, what happens to f of x? Well, if x gets close to 3 on the left, we're getting close to y equal 2. But as x gets close to 3 on the right, we're getting close to negative 2. So that limit does not exist, and that means that this entire limit does not exist. So you have to have both limits exist. Now, if we got closer to a number there, we could put that number in, and then we'd look at g of x as x approaches 3, and it looks like the g of x values get close to about maybe 0.7, and we can plug that 0.7 in there, and we get a number not in this case. What about the limit as x approaches 2 from the negative side, f of x over g of x? So while by properties of limits, this is equal to the limit of f of x as x approaches 2 from the negative side, divide by limit g of x as x approaches 2 from the negative side. So let's look at our f of x. So as x gets close to 2 here from the negative side like this, so values close to 2 but less than 2, so that would be like 1.9. So we come up here and go over. Looks like our f of x values are close to 5. So on the top, that's 5. Limit of g of x as x gets close to 2 from the negative side. So here's 2. As we get close to 2 from the negative side, we're going to go up to the graph and come over. Looks like our function values are getting close to 1. So that's 5 divided by 1, which is 5. Here, g plug in 0. So we're looking at the function g at 0. We're down here at height negative 3. So that part's in negative 3. And then the limit of f of x as x gets close to 1. So 1 is right here. On both sides, as you get close to x equal 1, your function values here are getting close to 2, 4, 6. So minus 6. This minus sign is right here. So negative 3 minus 6, negative 9. Limit of f of x times g of x as x approaches 2. So this, by the properties of limits, again, is limit of f of x as x approaches 2 times the limit of g of x as x approaches 2. So f of x, as x gets close to 2 here, either from the left or from the right, you go up to the function and over, and your function values are close to 5. So this piece is getting close to 5. And then limit of g of x as x gets close to 2. well, let's see. On the left-hand side, your g function values are getting close to 1, but if you are close to 2 on the right-hand side, come up, they're getting close to 2. There's a jump in the graph there. That does not exist. So 5 times something that does not exist is going to be a limit that does not exist. So sometimes they don't exist. Here, limit as x approaches 6, that should be from the plus side, x cubed f of x. This will equal the limit of x cubed as x approaches 6 from the plus side times the limit of f of x as x approaches 6 from the plus side. Well, this is just a polynomial. You can plug in to get the limits of polynomials. So that's going to be 6 cubed. And then here, as x approaches 6 from the right, for f of x, so here 2, 4, 6. So here is 6. As you come into 6 from the right, your function values here are getting close to, looks like 3. Right here. So this would be 6 cubed times 3. I believe that is 6 cubed is 216. Yes, and then times 3 is 648.